Good afternoon. We are live. I'm Sebastiano Tofaletti from the European Digital SME Alliance. We are live again with another episode of Digital SME Live. This is a streaming event where, as usual, we bring you speakers and experts to talk about digital topics that are relevant nowadays, and especially they are relevant for small and medium-sized enterprises in the IT sector, the digital SMEs. I'm here today with three very distinguished speakers, three top experts, I would say, which I will introduce you shortly. We want to speak about additive manufacturing, so 3D printing, this innovative technology that is poised to disrupt the what we call the value chains, the global value chains, everything that happens from the first manufacturing of components, shipping, etc., assembly, and that brings the products to the shelves when we go and buy them. So, the 3D printing is something that is, as I said, poised to possibly disrupt these global value chains. We have seen with the COVID-19 crisis that the crisis has highlighted shortcomings in the traditional value chains, because different states, different governments were trying to protect their population and even regions, and they started controlling their borders, and we were struggling to procure safety equipment. For instance, we were struggling to procure even hardware in some cases for the IT sector. This is a situation which the situation of COVID-19 obviously has highlighted how weak the global system is, and many people now believe that the 3D printers and automated factories could be a new wave of industrialization, a new economy, a new way of manufacturing and delivering products. So we are here nowadays with today with three speakers, three guests that will help us understand better this topic and see how it could affect, it could impact our lives and our economies. I have Lucian Cernat, who is the Chief Trade Economist of the European Commission in DG Trade. I have Lin Kayser, an entrepreneur, CEO of a startup, a small company called Hyperganic, which is small, but he will tell us very successful. And then I have Stefano Capezzone from Italy. Stefano is the chairman of and co-founder of Sistemi Group, which is an Italian fab lab, so a company that is really involved in 3D printing. As always, our audience is on YouTube, Facebook, and Twitter. And I'd like to ask everyone who's out there to feel free to ask us questions via the chat, via the comments in the social media. Also, if anyone has comments and wants to suggest topics for the next episodes, please feel free to send us an email to live@digitalsme.eu. Let me start this conversation by going to Lin Kayser, who's a successful entrepreneur, and he's really focused on additive manufacturing and 3D printing. You authored recently a very interesting article, Lin, called "The Digital Physical Product Economy." What do you mean by digital physical products? Is this a new category of products? Is this something you created or somebody else created it? Can you explain us a little bit what you were meaning there?
Thank you, Sebastiano, for the kind introduction. I don't think this name, digital physical product, has been used before, so I probably coined it. but it explains pretty well what it is. So in our current world, we fully understand physical products. I mean, it's the products around us, you know, it's physical things that you can touch and that you can trade. You know, they are usually manufactured in big centralized factories somewhere, usually where it's cheapest to manufacture, or where there's the most knowledge on how to manufacture them. And then they are shipped to the end user, usually assembled from many different parts. And all of this shipping and assembling and all of this is done in physical form. So you need to be physical present. The product needs to be physical present in order for it to be assembled and then shipped to the end user. And on the other hand, we have digital products. Now, digital products are products like software. Today, they are products like music. You know, music used to be a physical product. You know, you bought a CD or an LP before. And now, of course, you know, everybody's streaming it or trading it digitally. And the interesting thing that we have seen over the past couple of years is that we are now at the point where we can work with physical products digitally. And one of the key enablers for that is additive manufacturing, also known as 3D printing, industrial 3D printings. So you can use an automated printing process to produce an object from a file. And you know, during the COVID crisis, we have seen a number of examples like that. So there were a lot of great ideas about how to print components for masks or print components for respirators. And interestingly enough, these objects were all worked on digitally and then distributed digitally and then printed wherever people needed them. And I see that in a world full of trade barriers and full of lockdowns these days, this can be a new enabler for a new class of products, and I call them digital physical products. They are worked on digitally, they are innovated on digitally, they are collaborated on digitally, and they are traded digitally, but then they are manufactured locally using automated factories that have additive manufacturing at their heart.
Right. I see. Thank you very much. It's a very short but interesting introduction. So you mean these products will basically be manufactured by a 3D printing, not on the other side of the world, but each time where the customers are, so close to the markets, essentially. Is this correct, Lin?
Yeah, exactly. And the interesting thing is that, you know, in digital products, we have worldwide collaboration everywhere, right? You know, if you, for example, if you need a new logo for a new company, you can work with people all over the world. You know, there are platforms that enable people to work in you know, developing countries or emerging countries and contribute to this digital economy. And when you look at physical products, it's much harder. You know, these emerging economies and even developing economies, it's much harder. Even they have challenges with their supply chains. So it's really hard to ship physical products around. But if you ship the physical product in digital form and manufacture it at the end user's location, then people can contribute in a much broader sense. And I think this is very, very critical, because we need, for innovation to happen, we need basically every brain all over the world to contribute. And right now we're locking out a lot of people. You know, if you don't have access to a working physical supply chain, then it's very hard for you to work on a physical product right now. So we can disrupt this by having digital collaboration on physical products. And by the way, it's not just 3D printing. I call it digital manufacturing. There's more than 3D printing. 3D printing is at the core, but of course, 3D printing is not the only part that needs to also be automated, because not everything can be done using 3D printing. But even very advanced things can be done using 3D printing. I have an example here. Now, this is a rocket combustion chamber that was completely 3D printed, and it only was worked on in digital form. There was no physical assembly or anything, right? So you can do things like that completely digitally in a distributed way without being physical present.
Oh, Very nice, very nice. Thank you for showing that. Let me switch. Having had that introduction from him, let me switch to Lucian Cernat, who is Chief Trade Economist at the European Commission. And maybe Lucian, you can give us the point of view of the European Commission. How do you think? Do you think this is real? Do you think this is really going to disrupt the value chains? And do you think this is going to have an impact on the investment and trade around the world? And of course, what impact will there be impact be positive for our companies and citizens in Europe?
Yes, thank you, Sebastian. Hello, everyone. I'd like to start by putting a small disclaimer on everything I'm going to say today. I know you asked me directly to say what the European Commission thinks about 3D printing, but I'm afraid I'll have to disappoint you. Since I'm here today in my personal capacity, I cannot, I do not represent the European Commission, and whatever I'm going to say, it should not be interpreted as an unofficial position. I think there are many departments in the European Commission who are directly heavily involved in the future of this industry, and there are many colleagues who would know a lot more about the nitty-gritty and the rocket science of producing that piece of equipment that Lin just shown us. What I wanted to do today very briefly to set the discussion is to understand, at least from my perspective and the department that I work in, the DigiTrade, in the European Commission department dealing with global trade and global investment. I think for us, it's equally important to understand the implications of 3D printing for trade rules, for global trade and investment rules, and for the future. So what I'm going to say is not if 3D printing is going to change the world, not when either. I don't know if I have a very definitive answer to if and when, but I think as good policymakers, we should be prepared just in case 3D printing becomes a new normal. We should be prepared and ask ourselves, are trade rules and global investment rules ready for entrepreneurs like the ones today in the panel to develop their businesses globally? So I think this is my starting point of the discussion, and what I wanted to show you in a couple of slides in just a minute is, in a way, to put 3D printing in some sort of perspective. Since you mentioned that we are now live on so many platforms and we live in a digital world, the world was not like that until recently. In fact, for many centuries, the world was a very, I would say, very boring place. It was not full of the exciting technological innovations. For centuries, we were reliant on a small number of inventions that the human mind put together in an operational, productive way. And it all changed more or less from the steam engine. From the steam engine, the world has really become a technologically exponential world. We had a massive increase in all these technological innovations that were actually transforming our lives one century after the other. So if we were to move from centuries to decades, I think this is where I could show you my first slide, if the audience could have a quick look at also the exponential evolution of 3D printing activities. So by now you should have on your screen a graph with global 3D printing revenues from one of the most respectable consultancies in this area, I think. And you can see that over the last 2 decades, there's been very recently actually an exponential increase in the activity, 3D printing activities. You also see something else. You see that if you split the revenues of the 3D printing ecosystem, because we're not talking, as Lin said, we're no longer talking about physical and digital in a separate way. They are all fused together in these 3D printing activities. But what's interesting, at least to me, is that if you look at the share of services, the value of services that surround these 3D printing activities, they are more than half. So according to this data, around 60% of the total value of the 3D printing activity in this economic ecosystem is actually in the services, in this CAD files, in all the design, in the engineering, all the patterns that you may actually need to embed in your actual production. We also have actually a very big if and one question, because if you zoom out from this chart and you ask yourself, how much is 3D printing in the big scheme of things in terms of the share of global manufacturing? 3D printing, despite its exponential evolution in the last 2 decades, is still less than 1%, according to the same consultancy, is less than 1% of global manufacturing. So if we are going to have a new normal and a fundamental industrial revolution from 3D printing, this exponential increase will really have to continue at an even faster pace in order for us to see a disruptive change in a macro sense in the next few years. But be it as it may, as I said, I don't have the answer to if or to when, but I think if and when this is going to happen, we need to ask ourselves a few questions as policymakers. And this is the first one on the slide, is the reshaping of the global trade and investment flows. Is it going to be so dramatic? That's the question that I wanted to briefly address in my next slide. Here, I thought that 2 pictures should be worth 2,000 words and maybe 2 minutes of your time. So I wanted to tell you how globalization looks today. That's on your left-hand side of the screen normally, and how it's going to look tomorrow if 3D printing becomes the new normal. So global trade flows nowadays are structured on 2 silos. We have global flows of services, and you see 4 colors on services because we can trade services under the so-called 4 modes of supply. So here you see digital services in green. This is not the dominant one yet, but is growing very fast. The dominant mode of supply of services globally is what we call mode 3, which is FDI driven. In order to sell services, the most successful way to do so globally is to invest and have offices abroad. So this is the dominant way of selling services nowadays, also with digital services growing very fast. Now, if you look at the goods trade nowadays, we have a large value of traded goods. In fact, few people know that the total global trade in services in actual fact is bigger than global trade in goods already, if you account for this mode 3. But if we look at the goods trade, we see that we already have this digital embeddedness. We have a lot of services that are embedded in products already. And according to my estimates with a few other colleagues in OECD, there are many databases that will allow you to estimate this value of what I call these embedded services, or this is a 5th mode of supply. It's about 1/3 of the value of the good. So the value of everything you buy nowadays, if you wanted to split into material things and immaterial things, these digital services embedded in a product, it's already about 1/3 of the value of the product. But now fast forward to the future, imagine 3D printing is the new norm. Imagine a few other things, as Lin said, is not just 3D printing, it's all digital technologies embedded together, industry of Internet of Things, Industry 4.0, we have robots, we have artificial intelligence. Imagine all these, and how will the world look like in that scenario if this becomes prevalent? Well, there is no scale on the graphs, and that's deliberate because I don't want you to say, the chief economist predicted a 40% decline in global trading goods. No, I'm not predicting any particular number, but I think it's only fair to say that in the future, the value of global trading goods will probably shrink. So you see the value of goods in the future will be smaller than the value of goods today. There is also a fundamental difference in the structure of these goods. We will no longer trade in parts and components that will have to cross border 10 times. You know, a ventilator nowadays, since we are in COVID times, you probably wanted to know, a ventilator has over 2,500 parts. And these parts are actually coming to the manufacturer from many countries. They have to cross many borders. In a 3D printing world, that will collapse to probably a few parts that are still traded. So we'll have less trade in intermediates. We'll have a lot of trade in what I call here generically inks, meaning all kind of materials that you have to put in the 3D printing, and a lot more embedded services, the pinkish parts. So that will probably, if we believe the previous graph, that can actually double to roughly 60% of the value of the product. And there's also a shade of green because in this new world, the CO2 emissions attached to global trading goods will diminish for the simple fact that we will trade less, that we will reduce all this waste and the transport that is necessary to generate one particular product. Now, very quickly, if we move to services, I've already anticipated in this new world of 3D printing and this Industry 4.0, the digital services will become the dominant mode. we will all rely on these CAD files and a few other data-driven kind of interactions between manufacturers and consumers, etc. So digital services will be dominant. There will be less of a need for investments. There will still be foreign investment, don't get me wrong. There will be many face-to-face services where you need this physical interaction, you need an office abroad. So that will be a viable economic activity. But many of the products that nowadays are produced in China or Vietnam or in far locations, with 3D printing will come economically viable to also produce them in Europe. And I think at the end of the day, the fundamental message is that 3D printing may change the national comparative advantage, the way we think about global trade in fundamental ways. And what does that mean for policymakers? And this is my final point. We need to, as policymakers, we need to understand, and here I'm going to use a bit of a jargon from the trade policy world, but if trading goods is set to decline, then the value of one part of our trade rules, which is called GATT, the GATT rules, the rules governing trade in goods, will also decline. There will be less important to negotiate detailed tariff schedules on all sorts of parts. If that's true, then we will have to focus on rules of origin. We'll have to focus on export restrictions. If a country has the fundamental ingredient for an ink, for a 3D printer to work, and that raw material is subject to export restrictions, nobody can actually function efficiently. And as Lin said, we all need to work efficiently together to make the most out of it. So we cannot introduce new barriers that will affect 3D printing. If FDI will decrease and if digital services will increase, that means we have to be much more mindful and more attention to pay more attention to IPR rules. After all, if everything is CAD files, and if I just copy CAD files and I don't respect the rights, and I can just hack a printer, this is not going to be the world that you and I envisage in a 3D printing world. So we need to have strong IPR rules, strong data rules. We will have to have data protection. Cybersecurity will be extremely important. And I think I already mentioned that the world will be a greener place with 3D printing, at least from what I learned and I heard. I'm not sure how much, but I'm sure it's going in the right direction, this contribution towards less CO2 emissions. And finally, but not necessarily the last point, is that trading jobs, this equation, trading jobs, has to be probably again revisited. At the moment, 36 million jobs in Europe, 36 million jobs, which is 1 out of 7 jobs in Europe, depend on our ability to trade. Now, how many jobs will still be dependent on trade if the value of global trade and intermediates will decline, if digital services will increase? Will there be less jobs? Or do we need new kinds of jobs? Do we need new skills? I think these are fundamental questions for which we all need to find an answer before the change happens, because otherwise we'll have massive unemployment or shortages of labor in some situations. Thank you.
Yeah, well, that's very, very interesting. And I'm also happy, Lucian, that you said you are speaking on a personal basis, because the fact you are not officially representing an institution gives you certainly a lot of freedom to say very, very interesting things to us and to contribute very actively to this conversation. Lin, before I let you respond and give your opinion, let me also ask our third speaker here, Stefano Capezzone, to say what he thinks about it, because Stefano, you are yourself sitting in Italy, I suppose you're in Rome, at a 3D printing lab, which is also your company, I suppose. And so you can really tell us from the real voice of an entrepreneur who's active in that field, how it is happening, and what is your reaction to what you heard from Lin and from Lucian?
Yes, thank you, Sebastiano. Hi, everybody. Yes, I'm sitting in Fab Lab Ostiense, which is the largest of our Fab Labs. Our company runs several Fab Labs in Lazio, it's the central region where is Rome. Yes, I agree with Lin when he says that 3D printing that could be a disruptive technology about this new model of digital physical product, but it's not only a matter of 3D printings, because 3D printers are only the most iconic technologies of this new kind of manufacturing. There is a general model, and there is and this is a digital fabrication in general, which can be disruptive, because digital fabrication is associated to machines controlled by computer. We use, it's about 30 years that manufacturing uses computer numerically controlled machines. But a 3D printer, and as 3D printers, also other fabrication machines we have in our Fab Labs are different from traditional digital machines. A conventional digital machines needs to be set up. It's able to execute a program, but that program must be written by an operator. So we usually have a conventional design. It's not necessary to have a digital design because you have some manual work by operator. So it's this long and boring work before you can fabricate something is the main reason, because digital fabrication machine of conventional type are used in economy scale, big scale production. A 3D printer is the first example of a different kind of machine. All you need is a file. The machine needs not to be set up. You have a file, you put that file into the machine, and the machine builds the object. There is no setup, and so this is possible, a complete, a direct digital manufacturing, because you start from digital design and you go straight to digital production.
Stefano, sorry, let me ask you a quick question here. But how is this technology becoming nowadays affordable and scalable? Because if we think that this is going to disrupt the entire value chain, it needs to become, you know, something that can be scaled up. Is it nowadays affordable, or is it just too expensive?
Yes, now it is affordable, and this due to, for example, maker movement and open source movement, which breaks a lot of major costs associated to intellectual properties and patent pending on the most of technologies like 3D printing. Now we have machine like laser cutters, digital milling machine, which are very similar to 3D printers. This kind of machines are able to directly make an object starting from a digital design. They need no setup. They are a different kind of machine. Fab Labs is a standard of the digital fabrication laboratory based on this kind of technologies. Not only 3D printers, but also several fabrication machines which conform to the same paradigm. And this is the most potential disruptive model. Fab Labs was the first example of a possible network of fabrication facilities spread all over the world. If you adhere to that standard, you can design an object in order to be made in a Fab Lab. And if you design such object, you can produce this everywhere in the world.
Right, and Lin, maybe you can help me to elaborate a little bit on what the two previous persons said, because your company does something on top of that. It's not, you are not a 3D printing company or a digital manufacturing company. You are really an IT innovator here. So what is the kind of value that you add to what has just been said?
Yeah, before I get to that, I just want to comment very quickly on something that Lucian said, and I want to emphasize the impact that this actually has. So, I mean, first of all, Lucian said that about 1% of global manufacturing is 3D printing. It sounds very little, but then he also said, it's growing at an exponential rate. So, something that's 1% today is growing at an exponential rate can very quickly actually become quite significant. Now, the question is, how fast is the exponential rate, of course? But, there's this famous question, when something grows at an exponential rate, what was the value before it reached 100%? And then most people think, and it's 50%. So it's really fast. I mean, people have real trouble understanding what it means when something is growing exponentially. And there are many examples in the technological world where things came out of nowhere. Think about smartphones. 10 years old. 10 years ago there were no smartphones essentially, and now everybody has one, right? So it's growing fast, and it is already a significant portion. Then the other thing that I found really remarkable, because I think, Lucian, this goes against what a lot of people take for granted. It's that you said that trade will actually shrink. So we are at peak trade. A lot of people assume that trade will actually increase as more players come into the world. But I actually would agree with you. But what does that actually mean for policymakers that are currently planning, to put infrastructure in place for trade? Singapore just built a huge new container center, container terminal. So what does that actually mean that when we are actually at the peak already? And then the third thing that I find super important to stress, trade is emitting a lot of CO2. Trade is emitting a lot of environmental destruction. And if we can shave off some of the trade by moving to decentralized, localized production, we can actually address some of the challenges of the United Nations Sustainable Development Goals just by doing that. So this is really important, because this is also some of the reasons why we started our company. So one interesting aspect of additive manufacturing, 3D printing in particular, is that the complexity of the object that you're generating is actually not that important anymore. This is completely contrary to traditional manufacturing. In traditional manufacturing, you have to assemble things. Every additional hole that you drill costs additional money. So you're trying to keep things very simple. And so everything around us right now is actually relatively simple in terms of its shape and its functionality. Now in 3D printing, it doesn't really matter. All you're paying for is the material that you consume, and actually the printing process also goes faster the less material you consume. So even if you have something that's incredibly complex, but it uses less material than the traditional thing, it will actually be cheaper. And so the other thing that's super interesting in additive manufacturing is that every object can be individualized. So there's no specific reason why you should mass produce the same objects all of the time. And I have an example here. So this is a bicycle helmet that we designed. And one of the interesting things that we did here is that we started with a scan of the bicyclist's head. So we had a triathlete who was scanned in our office. And then we automatically generated this helmet. And there is an AI, an artificial intelligence component to it, because we automatically adjusted the structures according to crash statistics. And you can now update these crash statistics, and the helmet will regenerate and become better over time. And so this is a new aspect of additive manufacturing, that every object can be individualized, which means that the production can become smarter and better every time an object is produced, because you can feed back information from the field, about the performance of the object. And this is something that is not the case in traditional manufacturing. In traditional manufacturing, you build all the tooling and build all the object, or the factory essentially for the object, and then it becomes really complex to change something. So innovation is really stifled. Innovation is really slow in physical things. If you compare the speed of innovation between physical things and digital things, there's just no comparison right now. And additive manufacturing and digital fabrication are going to change that. And this is really good news, because a lot of the challenges that we have today in the world have to be solved through physical products. If innovation is slow there, then we are not going to be able to meet these challenges.
Yeah, you say this. Now there is an very interesting parallel between the innovation flow that could happen with these digital physical products and what is already happening in digital services like software. Software has shown to be, a model that innovates in a super fast way because it is just not that much more complex to write new lines of code. As well as, on the other hand, it is very complex if you have to drill more holes in a piece of a machine or in a component of a product, or make it just shape it differently. This becomes a manufacturing complexity that is difficult to face. Whereas in software, things can be incrementally improved in a very fast way, and also the feedback you can have from the people who are using it can happen, almost simultaneously as we use the software itself. Going back to Lucian, because what you said, really triggered a lot of reactions, and I think you made a very, very interesting analysis. It's very good to see that people at our institutions are already looking at those things. How they can impact the future of our lives. What would you like to say something about this very obviously interesting connection between digital manufacturing and the green goals that the Commission has now set for the next years for Europe to become, a green economy, cutting CO2 emissions. So, is 3D printing and digital manufacturing really part of the strategy that the European Commission has put forward, or is it just, one of those satellites, meteorites that comes and you never know if it is really the technology that we are investing in?
Well, thank you for those questions, Sebastiano. Maybe I would begin first by reacting very quickly to what Lin said earlier, because these are extremely interesting points, and I wanted to clarify some of the things I've already said. First, I know very well that there is, and I would not claim that I have certainties. I know that there is a debate and uncertainty about the future of the value and the volume of trade if 3D printing becomes the dominant technology. There are examples of the hearing aids, for instance, and also for other dental implants and medical equipment where the introduction of 3D printing actually increased trade values for a number of reasons. The devices became cheaper, so many more people could afford them. The devices still required imports of raw materials, and then clients were abroad, so you would not have printing facilities in every single country. You may have printing facilities in certain regions, in certain parts of the world, and then you have a regional distribution chain. So the evidence suggests that in some cases, the introduction of 3D printing may actually increase trade for all these reasons. My point was broader and actually based on a very simple rule of thumb. At the moment, 60% of the value of global trade in goods is trade in intermediates. Now, if we reduce the number of intermediates, if a machine no longer has screws and bolts and nuts and all sorts of other little pieces that are all produced in the cheapest and most efficient way around the world, and instead you have the whole piece, the final component produced in one place, no matter what place it is. It could be at home, it could be the country next door, or it could be a remote place. But the fact that 3D printing, the design itself, is reducing this complexity of the number of things that we have to actually screw that together. That in itself is a powerful force. And if we at the moment have 60% of trade, which is trade in these parts and components, my conjecture, and I wouldn't mind if I'm wrong, but that's how I made my speculation, is that perhaps the value of global trade in goods because of these components will decline. But as I said already, the structure of trade will change as well. We will trade a lot more in other things. We will trade a lot more in these raw commodities that you need to produce the inks and the parts for the 3D printing. We will trade a lot in 3D printing. I mean, at the moment, you don't even have the codes to identify 3D printers in official statistics. Yeah. That's probably one other recommendation. We better have these codes in order if we want to monitor the phenomenon. But this will also increase a lot. So in the end, there will be a lot of changes also on these comparative advantages. Perhaps simplifying, but you could think of nations being competitive in one of the three things that will matter in the future. You can be competitive because you have the inks, you have the raw materials, and you can do the ingredients that a 3D printer would need. And many countries, particularly developing countries, will be very competitive in that activity. Then you'll have the 3D printing machine. Not every country will be able to produce 3D printers. So some countries will be highly competitive in actually manufacturing 3D printers. And yet others will be very competitive in doing the design. So these are the three main pillars of comparative advantage in a 3D printing world. You have to choose which one you belong to. You are a designing country. You have natural endowments. Europe doesn't have, so I don't think we would choose that one. We would probably be very good at printing techniques. We would do very well at producing the machines, the 3D printers, and we'll be very equipped to put the two together. So we will still need trade, of course. And the last point that I think Lin rightly made, but I would add a footnote to it. It's true that there are some CO2 emissions linked to trade, but in the great scheme of things, if you take every single economic activity, even nowadays, trade is not a major contributor to CO2 emissions. So of course, we could reduce further the emissions that are linked to trade. But just to be factual, at the moment, trade is not the major driver of CO2 emissions. There are many other economic activities that are far more polluting than trade. And this is where the attention of the European Commission is. Now, I think I also owe to the organizers to at least mention for once one important acronym in many European policies, and that acronym is SMEs.
Thank you for
SMEs are
that.
essential for many policies. They are essential for EU trade policy, and very soon will, in the near future, will release a new report, a comprehensive report on the contribution of SMEs to European trade. SMEs are critical to European competitiveness. In that report, you will see indicators on this export competitiveness for SMEs, and in many sectors, SMEs are more competitive than big firms in Europe. That's probably surprising to people. We'll also have indicators on the CO2 intensity of SMEs engaged in global trade. And I can already give you one headline. It's 70% or so of SME exports are in low and medium intensity CO2s. In other words, the SMEs that export in Europe, they are not this CO2 intensive kind of polluting activities, quite the contrary. And we also have a metric for the digital intensity, which I think that is really the topic of today's conversation. And you can see for yourself when we will release the report, how we place each other by country, by sector in this digital intensity metric. The good news is that many exporting SMEs are well placed in what we call in that study medium digital intensity. But I think 3D printing is not medium, it's probably in high intensity. And only a small share of European SMEs that export today, they are very competitive in that sector, which is probably an area where we should pay more attention. So there is a good basis to start, both in terms of digital intensity and CO2 climate change for trade and SMEs. And 3D printing offers new opportunities that we need to really pocket as much as we can.
I see. You mentioned, Lucian, these three components of a successful economy. You can be either, successful because you have the raw material, or because you will do the 3D printers, or because you will do the design. Now, if Europe, I suppose, as you said, it's probably one of the biggest components for Europe is going to be doing the design of the products. Do you think we have the right framework in terms of protection of the intellectual property? Because I suppose it is going to be very relatively easy to copy a design in another country and produce it over there. And how am I going to check that that happens? How am I, if I'm the owner of the design, how am I going to make sure that I am protected? So do you think there is any scope for improvement in that respect? And what can we do in terms of trade negotiations, for instance?
Well, Sebastiano, IPR is already it's been for a while a top negotiating priority for the European Commission. We have very strong IPR rules in all the rules, the trade rules, including at the WTO, but also in our bilateral free trade agreements. And I can only speculate that the importance of IPR and fighting counterfeits would increase in a world where 3D printing becomes the norm. But again, going back to the point that Lin made, 3D printing doesn't happen in a vacuum. It's part of a digital ecosystem, and many other technologies will actually interact with each other. And just to give you one example where we are also very active nowadays to understand the implications for trade policy, blockchain. If you have this traceability of CAD, of CAD design files from the designer itself to the manufacturer all the way to the client, that will allow for a legit trade to happen and for the illegal trade and for the illegal activities to be immediately weeded out from the system. So there are many examples already where blockchain and these trust technologies will make a huge difference, and I expect that for something that's as crucial and as easy to actually forge illegally like a CAD file, we would need to have very strong IPR rules and very strong technological solutions to ensure its paternity. Not just paternity, but also to ensure that it's not tinkered with, because you can also have serious issues if someone modifies slightly a CAD file for that rocket sign, for that piece of equipment that goes into a rocket engine. Imagine someone will simply modify it a little. Then the whole piece will blow in your face, and that will be a disaster. So we need to ensure a lot of safety and security issues in the new system, which shouldn't be overruled by the business community.
Yeah, I see, Lin, you're nodding. Would you like to add something to that?
Yeah, absolutely. I mean, in the end, this is not a unique problem. I mean, it is a problem that has had to be solved in the digital economy over and over again, right? So intellectual property, once it becomes virtual, is of course much harder to limit the illicit distribution of it than if you have like a physical product where you can put a hologram on it and ship it as a physical thing. So this is not a new problem. The interesting aspect is, of course, that it becomes a much wider problem because it affects essentially every product around us. Now, one of the things that I want to caution against is when we talk about digital products, we often think about just CAD files, just like the outer shape of something. And the outer shape of something can be very easily copied. Now, Lucian, you actually alluded to an interesting aspect of additive manufacturing, that you can produce objects that don't require assembly. So it's actually not so easy to find out what are the components and how this all works together. And so the machinery that we are going to build is going to be significantly more complex than what we have today. And the production process will be an integral part of the file that you send. And so it is actually not so easy to just copy it. I would compare it to the microchip industry. If you think about the microchip industry, they actually have digital physical products. They have fabs all over the world. They're actually not simple operations. I mean, these fabs cost sometimes billions of euros. But the way you send stuff to the fabs is actually very standardized. But the file is just one part of the equation. The actual integrated manufacturing process is the other part of the equation. And so I think it's not so bad. So we think of a world where everything can be copied and there's no revenue anymore. Well, if it is so simple to copy it, maybe it deserves to be in the public domain, and this brings us back to the fab labs. But if it is a highly sophisticated product, it's also not easy to copy and not easy to manufacture. And the machines that will manufacture it are also not going to be simple machines.
Yeah. Let me ask Stefano, as you are the one who is really in the field now, and on your back we see really a digital manufacturing facility. So what is your take on this concept of protecting intellectual property and using 3D also to counterfeit products? Is it actually the case, especially when we are talking about not very complex products as chips?
Yes, sure.
As Lin mentioned.
Intellectual properties protection is sure a problem in digital fabrication. It is possible to copy a design for a conventional object, but you have to do reverse engineering. You don't have access to the digital design. In a model such as digital fabrication, we distribute digital design. So it's simpler to copy that, but it's also simpler to do little change on digital design and try to bypass intellectual property. This is the main problem now. A lot of our customers are afraid about this possibility because in traditional manufacturing, usually you don't distribute your digital design. So sure, it's possible to copy, it's possible to reverse engineering an object. But if I have the original design, it's simpler, it's faster to have it, and often to change it in such way to bypass intellectual property protection, especially in a context where there are different laws in different countries. So it's a problem.
All right. We are getting towards the end of this conversation today. So I'd like to ask the three of you to give me your last statement, your takeaway, or the thing you didn't manage to say for today's conversation. I'll start with Lucian. How would you like to sum up your contribution here?
Well, I think for me personally, the occasion to participate in such a live conversation with experts in the real world is always a major benefit. As a policymaker, we are always interested in the ideas and the feedback of the people who will eventually be affected by the rules that we put in place. And we want the rules to really help their businesses. So interacting and sharing ideas is the fundamental way in which we brainstorm on new ideas. And again, it's not very easy for a public servant to come up with new ideas in a world governed by disruptive technology. So guidance is always more than appreciated. But it's also important for us to be able to translate the policy implications also back to businesses so that they can also anticipate and they can adapt to these emerging rules. Some of the rules will not change, as I mentioned in my intervention. Some of them will become more important. But I think there will be one or two elements where probably new rules need to be developed. And when new rules need to be developed, we need this conversation between policymakers and the business community to ensure that they are developed in the most efficient way.
Yeah, and obviously we as the European Digital SME Alliance are there also to make sure that that conversation happens, especially linking the Brussels policymakers, which are sometimes a bit far from the reality, with the real businesses as we have today. Lin, your turn now. How would you conclude this conversation? Your last words.
Yeah, I mean, there's a couple of things that come to my mind when I think about the world right now. I mean, there's some concerns that I have. You know, first of all, we have a lot of global challenges that we need to address, and a lot of them involve physical things. And you know, for the past decades, you know, I've been quite frustrated with the pace of innovation in physical things. Now, I'm a software guy, you know, so for me, you know, innovation was like a constant. I witnessed the entire PC revolution, you know, from the very first PCs to, you know, the sophisticated objects the sophisticated computers that we have today. Then I saw the rise of the internet, and now the rise of you know, mobile devices, and all of them that's happened very fast. But if you look at you know, most of the other objects around us, they haven't really changed that much. If you strip away all the decoration from a modern car, it doesn't really look that different from a car in the 1950s or 60s. So we need to accelerate innovation dramatically. And one way is through digital fabrication. And the reason why we started our company is because we think we can help people create objects much faster, iterate much faster, and really move the engineering of physical objects under Moore's law. You know, Moore's law has governed the computer industry, of course, for many, many years. So this is one aspect. The other aspect, what I'm a little bit worried about is, you know, these barriers to trade that are, you know, being erected everywhere. You know, trade is one of the most fundamental inventions of humanity. You know, it allows us to work together on shared solutions. You know, have a competition between the best solutions all over the world. And you know, as long as people trade with each other, they don't usually fight wars with each other. And so what we're seeing right now everywhere, you know, being in the United States, but also in other regions in the world, is that trade barriers are being erected. And this is really the worst thing that we can do right now, because we need to work together to actually solve these challenges that I mentioned earlier. So my hope is that through digital physical products, you know, products that exist in the physical world but are traded digitally and innovated on digitally, that we can actually overcome some of these barriers that we're seeing everywhere. And you know, Lucian, I'm very encouraged by hearing that you are thinking along these lines in terms of policy. And you know, just to underline that that very important statement that you made, innovation is usually coming from small to medium-sized businesses. And so we need to make sure that these thrive in our ecosystem. Unfortunately, here in Germany, we have a lot of these, but we can do a lot more to help them you know, gain more traction, because our focus, you know, just also with the COVID help, etc., is very much on the big spectacular ones, and not so much on actually the ones that employ most people in Europe and bring most of the innovation and are going to be the future of Europe. So that's it from my side. Thank you.
I can only reiterate that definitely SMEs are an engine for innovation and also for growth and employment, by the way. Stefano, would you like also to conclude with some final remarks on this conversation of today?
Yes, first of all, thank you for this interesting conversation. And yes, I think that digital physical products could be very disruptive in changing global supply chain towards a more sustainable model. But I think also that is not a straight road toward this goal. Because I think it's necessary a mindset change in digital design. Digital physical objects needs to be designed differently from conventional physical objects. Fabrication technologies is always a challenge during the design phase. A designer have to think how to make the objects, the final objects. And so if the world system will not change in order to provide an effective distributed manufacturing model, the new technologies such as 3D printing could be innovative by itself, because as we say today, a lot of things can be done with additive manufacturing, new kind of objects, new geometries, and so on. But a digital distributed manufacturing model is a more challenging goal.
Thank you, Stefano. With that, I think we conclude today's episode of Digital SME Live, Additive Manufacturing and the Future of Global Supply Chains. We were with speaker Stefano Capezzone, Lucian Cernat from the European Commission, and Lin Kayser. A record of the live stream will be available on our website, www.digitalsme.eu, and our social media channels. Next week, we will discuss 5G opportunities and challenges for SMEs. So tune in on June the 2nd on our Twitter, Facebook, and YouTube channels. Thank you again to our speakers and to all the viewers who watched this live discussion. I'm Sebastiano Tofaletti. Goodbye.